This is lesson 10.1.1. We're going to be simplifying rational expressions. So we're going to understand the restrictions of a rational expression and simplify them. So we've simplified rational expressions before, like 20 over 60. How could we be able to reduce that? Now, a way for us to reduce it is we have to simplify common factors. And so if we were to factor 20, we could factor it into 2 times 10 over, and then 60, we could say 6 times 10. Well, the factor of 10 is in common, so they reduce. Well, in 2 and 6, I can factor 2 into 2 times 1, and then 6 would be 2 times 3. And then the factors 2 reduce, and so I'm going to be left with 1 over 3. Now, I understand that we have that shortcut in our head. Oh, you divide top and bottom by the same number. It is a good shortcut, but the problem is that it kind of takes away the visualization of what is happening. And essentially, we're reducing common factors. A factor that's the same on top, the factor that's the same on the bottom, things will cancel out. Things will reduce. And so the implication here is when you factor, you're turning it into multiplication. And so they have to be, the items that reduce, or the expressions that reduce, have to be in a form of multiplication, or you cannot reduce them. And we'll get back to that idea in a second. But now let's look about simplifying 10x over 10x. Now, yeah, the 10s as a factor reduce and the x as a factor reduce. But let's take it a step further. What if my x is 0? Well, if I plug in 0 into this, I get 0 over 0. Right? If I plug in 0 into the original, 10 times 0 is 0 over 10 times 0 is 0. I get 0 over 0. Am I allowed to divide by 0? The answer is no. And so what's going to end up start happening is the moment that we start including variables in our rational expressions, we have to worry about the values of x that have to be excluded. And so when we go through and we simplify a rational expression, we have to pay attention to that. And that kind of segues a little bit into domain. Remember, there are certain restrictions and whatever functions that we have. It's that same type of concept. There are restrictions to the values that exist in our variables. So to find the variables that need to be excluded, we set the denominator equal to 0 and solve for the variable. That's kind of like what we don't want, or that's how we find what we don't want, right? Because we can't divide by 0, so if we set the denominator equal to 0, we can find those values. So let's simplify some of the values and state what the values that need to be excluded. Well, in this first example, because these are all factors, right, they're all being multiplied, so I can just say h over h. That cancels out, and so I'm left with h times k. To find what needs to be excluded, we set the denominator, which happens to be h, equal to 0, and we say that it can't be those values. Well, h is now by itself, so h cannot equal 0. And so those are the two answers that I'm looking for here. All right, example number 2. This is being multiplied. So because it's being multiplied, these are factors. Well, the factor that's the same top and bottom that's going to reduce is the m plus 6. And so I'm going to be left with 2m minus 5 over 3m plus 1. So that's what it looks like when it's reduced. Now, what are the values that need to be excluded? Well, we set the denominator equal to 0. And you set the original. So I'm going to say m plus 6 times 3m plus 1 equals 0. This is the zero product principle. So you set each factor equal to 0. minus 6 on both sides. And on this one, minus 1 divide by 3. And so you get m equals negative 1/3. And so m cannot equal negative 6 and negative 1/3. So those are my excluded values. Let's look at example number 3. Now if I group this, now we can notice that those are going to be the same factors. Now a common mistake is when we cancel things out, we just think there's nothing left on top. No, there's a 1. So this is going to equal 1 over 4x minus 1. Okay, now we look at the original, and we have to look for what's excluded. So 4x minus 1, 3 times 2x, we have to set that equal to 0. So the zero product principle says I set each of those equal to 0. So 4x minus 1 equals 0. 3 minus 2x equals 0. So add 1, divide by 4. I'm going to add 2x and then divide by 2. So x cannot equal 1/4 and 3/2. And so that's going to be my answer there. Now you guys should get these down. These are good examples. Now sometimes we're going to be getting scenarios in which we're going to have to factor first before we do anything. So another really bad instinct that we have is a lot of the times we look at these 2x squareds and we think, oh, they must reduce because I see the same thing top and bottom. And that's why I emphasized in the beginning of this lesson, you can only reduce common factors. That phrase factor means multiplication. Literally means multiplication. Well, that x squared plus 6x is not multiplication. So because it's not multiplication, you have to think of these all as one thing. It's like grouped together as one big thing because it's that times 1 right now. And so that's why we learn factoring techniques. We learn to factor because the process of factoring then allows us to write it as multiplication to see if things reduce. So on example number 4 here, the values on top, right, the X box method, a times c, b on the bottom, the factors that add to that is 3 and 3. So this is x plus 3 times x plus 3. And on the bottom, that's a difference of squares. That's the a squared minus b squared. So that's going to be a plus b, a minus b. And so now it's factored. That means multiplication, x plus 3 times x plus 3 over x plus 3 times x minus 3. Now we can reduce common factors. And so I get x plus 3 over x minus 3. This right here, that is my reduced expression. Now set the denominator equal to 0. So I get x plus 3 equals 0, x minus 3 equals 0. So x is negative 3, x is 3. So x cannot equal, because if I plug these values in, you get a 0 in the denominator, negative 3 and positive 3. Those are my exclusions. Number 5. So factoring on top, looks like there's an x in common. So I can factor out an x, and so I get x plus 4. And on the bottom, there's a 2. So then you get x plus 4. And so now those cancel out, and so you're going to get x over 2. That is the reduced expression. But now setting the bottom equal to 0. Solving for that, subtract 8, divide by 2, x equals negative 4. So I can say x cannot equal negative 4. So in conclusion, what did we learn today? Well, we learned about reducing rational expressions, and how do we find the excluded values? We set the denominator equal to 0. This does conclude our lesson. If you have any other questions, please leave them in the comments.